This video is going to focus on the reference mapping. So this is the first significant computational step in this whole workflow. It lays the foundation for the rest of the workflow and has multiple steps in setting it up. So this will probably be one of the longer videos. So this is where we left off. We have the trimmed paired Illumina reads, or trimmed paired Illumina reads. Some of the stuff we no longer care about, the report, discarded sequences. We only want the trimmed sequences, which are going to be fed into the map reads to reference. So we have these trimmed reads. We're going to add a new element, but before we do that, we're going to save as, and we'll call this step 3, map reads to reference. Okay. And so there's an element for this. Map reads to, there it is, map reads to reference under the resequencing analysis. And there it is, I put it up top. Okay. So for this, there's a number of different elements which need to be configured. The first one, obviously, is we want to take these trimmed sequences and feed it in. So here we'll delete that and make the connection from the trimmed sequences to reads. But one of the biggest things we need to configure is the reference. Okay. Now we don't currently have the reference in our workflow here, but we are going to go and find it. And it's fairly easy how to do this in CLC. And there's a couple steps involved in it also. So here, if we want to download the reference from NCBI. So here we go into NCBI, and let's blank that out because we'll just enter it in again. You can search NCBI with reference IDs and pull down the file, say nucleotide protein EST from NCBI. So we know that the Wuhan reference that we want to use has the succession number, the MN908947. And we could say start search. And so it searches, and we could see here's that accession of the MN908947. And we're going to want to download this. Let's see. Oh, yeah, right here. Download and save. So we're going to download and save. We're going to download it into our reference folder here. And now we can close this search. And now we don't want to save anything. We'll go to our reference folder, and we can see here's that genome with annotations. So now that we have it downloaded, we have to put it into a form that our workflow can use. Right now the workflow can't use this form because if we look at, I think it's this one here, this kind of sheet icon, you can see this is the full-on reference, all the information on it, coding regions, genes, UTRs, etc. And all we want for a reference sequence is we want the genome part of this. Now the way you extract that genome part out is, and pay attention because this took me a while to figure this one out. You could highlight it or you could choose it when we get in there, but you're going to go to your toolbox, and then there's this function called track tools, or menu item called track tools. And what we want to do is do this track conversion and convert to tracks. So what this convert to tracks function is going to do is it's going to parse out the different elements of this record into the genome, the CDS, the UTRs, etc. So we can grab just the genome aspect of it for our workflow. So we'll say convert to tracks. It's already selected that. We'll say next. And then you're going to say create a sequence track, and we'll use potentially some of these annotation tracks later. So what we'll do is make sure that we have selected all the different annotation types for tracks. And I think when you, by default with yours, it may look like something like this where only CDS is selected and you have to select the others and move them over. Done. So you can see all 5 elements are selected. Next. And then we want to save this, and we want to save it into the reference. So you can see it just populated this folder with all these different reference types, and we can click on any one of these and you can see that it's just the CDS against the chromosome. This one is defining the 3' UTR over here, etc. But the one we're most interested in is this one marked genome, and the genome is what we're going to use for our workflow. So you can see it's essentially just the genome sequence in there all alone. So let's go back, and here with a reference, what we want to do is connect to a workflow input. We'll move this out to the side, and then we're going to select that genome right there. So we're going to configure this input and say finish. And now you can see it says workflow input, and it's the genome track for that reference ID. And that's how you configure, how you retrieve and configure that input. We're not worrying about a masking track for this analysis. When it gets into the mapping options, we're using just the default options that are present here. And then you can export one or the other read tracks or read mapping, and read tracks are going to be used later on, so we'll use that as a workflow output, and we'll use this as a workflow output, the mapping report, because we will want to save those. And we could even, we talked about this in an earlier video, put this in a reports folder. So this will be the mapping report configured. And we're not going to worry about this unmapped reads. We're going to discard those. So right now, let's save this workflow, and let's try to run this. And we are going to use our reads here. Next. You could see from the configured input, it already knows where to grab the genome because we saved that in the workflow. We're going to save the results handling, and we're going to put those results into here, and we're going to call it step 3 read mapping. So okay, so now it's running. You can see the validation successful. It's going through the different steps, and this actually goes pretty quickly with one specimen. Okay, and we're finished. So if we go in and look at the results over here on the left, step 3 read mapping, we can see we still have our QC results from before. This still happens. And in our reports, we have our mapping report, which we can open up, and gives the percentage of reads mapped and the lengths. The other nice thing is it gives a paired read distance distribution, which is nice to have. But the kind of meat and potatoes of this analysis is this read mapping here. It's kind of what you would see if you imported a BAM file into CLC. Now this is kind of messy with the default settings on it, and because it's highlighting every variant, so every sequencing error that's found in here is going to be highlighted. So what I'll do is on the right here for this reads track, we can change all these colors and parameters, and I find it neatens things up quite a bit if we remove highlight variants. And as it reconfigures, you can see it neatens things up. We don't have to float the variants to the top. We don't have to highlight reverse paired reads. And then you can see things are much neater. Okay. And what's really great about the reads mapping view is you can go in and look at potential trouble spots here. So if you can select a region in the mapping, and then you go down to the bottom right here, and you can see zoom to selection, and we zoom to selection. So you can see where an amplicon is dropping out there in the sequencing. So for the Arctic amplicons, this one, if for some reason just isn't getting really good coverage, but you could also go in here and zoom into another region, and you can see the actual alignments here. So this is really, really nice. I actually use this quite a bit when doing some manual QC on the sequencing to look for problem areas and ways to potentially improve the amplicons for the sequencing. And down here at the bottom, if you just do this zoom fit, and it goes all the way back out, and you can see this. And you also get some statistics up here. You know, this one had 1 million reads, and the maximum coverage is 12,578. So, okay, so we just finished up this time with the map reads to reference. And as always, you know, we went to the configuration. If you wanted to learn more about all these parameters and what they are, you can hit the help right here and scroll down, and it will go into detail as to what all these parameters are and actually discuss at length a lot of the different algorithms that are used for this type of read mapping. Okay, and that is it for this video. Thanks.